All right, let's talk about something that's a huge deal in modern data architecture, knowledge graphs. If you're an architect or a developer, you know just how much those early choices can come back to haunt you. So let's jump right into the core problem they're here to solve.
I mean, who hasn't been here, right? You write what seems like a totally reasonable SQL query, you add a few joins to link up your tables, and all of a sudden, your performance just falls off a cliff. It's super common, and man, is it frustrating.
And here's the big reveal, the key insight. The problem isn't the individual pieces of data. The real bottleneck, the thing that's grinding everything to a halt, is how your database is handling the connections between them. It's all about the relationships.
Okay, so you're sold. A graph is the way to go. But right out of the gate, you hit this massive fork in the road. And this isn't just a small choice. We're talking about a deep philosophical divide that's going to define pretty much everything about your system.
So in one corner, you've got the property graph model. This thing is built from the ground up for raw speed and making traversals feel natural. And in the other corner, you have the Resource Description Framework, or RDF. Its whole reason for being is semantic purity and making sure data can talk to other data, anywhere. They are very different tools for very different jobs.
You know, the best way to see the difference isn't with some abstract theory. Let's get practical. Let's say you want to record when two people became friends. How do you actually store that since 2020 tidbit right on the friendship link itself? The answer to that question, well, it tells you everything you need to know.
Okay, first up, the property graph model. And honestly, it's just so clean and simple. Here, that relationship, what we call an edge, is treated like a real thing. It's not some second-class citizen. You can hang key value pairs, like since 2020, directly on that edge. It's just native. And because of that, it's crazy efficient when you go to query it.
All right, now let's flip the coin and see how RDF tackles this. Because of its strict subject-predicate-object world, you actually can't just stick a property on a relationship. The model doesn't allow it. So you have to do this structural gymnastics called reification. What happens is that single simple friendship link, poof, it explodes into 4 separate statements, turning the relationship into a node itself. You can see how this just adds a ton of complexity.
So you can see, this choice you made way back at the beginning, it's not just about how you store stuff. It completely shapes the world you're going to live in, and it determines what kind of superpowers your graph will have. This is where we get into what you can actually do with it.
So in the property graph world, it's really important to understand this distinction. First, you've got traversal. This is where you use a language like Cypher to find patterns you already know you're looking for. Think, go find all my friends' friends. But then you have graph analytics. This is totally different. This is about understanding the shape and structure of the whole network. Who's the most influential person here? Where are the hidden communities?
Now, RDF's killer app? Oh, it's got to be inference. This almost magical ability to discover new information that wasn't explicitly stated just by following a set of rules. And even here, architects have a choice. You can go with forward chaining, which basically does all the thinking up front when you load the data, or you can do backward chaining, which is a bit more lazy. It figures things out on the fly when you ask a question.
Look, a knowledge graph is awesome, but it's totally useless without good data. So the big question is, how do we actually feed the beast? The data pipeline is the absolute backbone of any project like this.
So for years, if you had a bunch of unstructured text, the go-to method was this pretty gnarly multi-step NLP pipeline. You'd have to, suck in the text, then run one process for finding names, another for finding relationships. It's super powerful for sure, but man, you really had to be an NLP wizard to pull it off.
But this is where everything changes. This is the real game changer. LLMs have just completely flipped the script. Now, you can literally just hand your text to an LLM, give it a smart prompt, and say, hey, pull out the important stuff for me in a structured way. I mean, the barrier to entry for building a knowledge graph from text just plummeted.
So you might be asking, why are knowledge graphs suddenly so hot right now? It's because they are the perfect antidote to some of the biggest headaches in modern AI. They're moving from just being a place to store data to being an active part of the thinking process.
And this workflow right here, it's the perfect example of that synergy. It's called GraphRag. And it's this really clever dance between the LLM and the knowledge graph. Basically, the LLM is the smart question asker. The graph acts as the fact checker, retrieving hard, factual data. And then the LLM takes that reliable data and crafts a beautiful, accurate, hallucination-free answer.
It's the best of both worlds. We've all been there, right? You ask an AI a question and you get something like this. It's the classic black box problem. A 92% confidence score, what does that even mean? It tells me what it thinks, but absolutely nothing about why it thinks it.
But check this out. When you plug in a knowledge graph, that black box suddenly becomes a gloss box. Your answer isn't just some random number. It's a story. It's a trail of breadcrumbs. We recommended this supplier because, look, here's the path. They operate in Europe? Check. They have the ISO certification? Check. And they supply the exact product you asked for? Check. It's clear, you can read it, you can audit it, it's explainable AI.
Okay, wow, we have covered a ton of ground here, from the deep architectural divides to AI workflows, so let's boil it all down. Let's get to the final verdict. When do you, the architect, pull the trigger and say, yes, a graph is what we need?
A lot of the time, the answer is just plain and simple performance. I mean, just look at this chart. When you're only doing a couple of joins, SQL is fine. But watch what happens as you go deeper into the relationships. SQL performance doesn't just get a little slower, it completely falls off a cliff. Meanwhile, the native graph query, it just hums along, fast and consistent no matter how deep you go.
Okay, so here it is, the golden rule. If you walk away with just one thing today, let it be this. If the connections, the paths, the hidden networks, if that's where the real value is in your data, then you need a graph. Period.
So here's a little cheat sheet to help you decide. If you're chasing connections deep into your data, you go with a graph. If you need to crunch big aggregates, stick with your trusty relational database. If you need to grab a whole object at once, a document store is your best friend. And for super fast lookups on a simple key, key value can't be beat. It's all about using the right tool for the job.
And believe me, this isn't some academic exercise. Think about the really tough problems out there. Trying to untangle a complex fraud ring, optimizing a supply chain where one little delay can ripple through the whole system. In every single one of these, the relationships aren't just part of the story, they are the story. And that's why a graph is the only way to go.
And last but not least, when you actually go to pick a platform, remember that not all graphs are built the same. You've got Neo4j, which is kind of the mature all-in-one package. Then there's Amazon Neptune, built for the cloud, separating storage and compute. And then you have TigerGraph, which is just a beast for massive scale analytics and parallel processing.
So we started this whole journey with this simple, frustrating problem. Why are my queries grinding to a halt? And now I want to leave you with a challenge. I want you to go back and look at your own systems, your own data, your own business problems, but with a new set of eyes. And ask yourself this one simple, powerful question. Because I guarantee you, the answer might just change everything.